Email address. You know how to do that. Spell your name right. Then you decide how long you want the experiment to run. Let's say 15 seconds. Type in 15, and the percent value of input. Oh me, maybe I should talk about something else first. I'll talk about something else first, students? Say yes. We're going to talk a lot about this. It's a block diagram. What do we call the stuff that goes in? Very good. What do we call the stuff that comes out? And what do we call this thing here? It's called the system. And what we're going to put in is percent over here. And what we're going to get out is whatever the output of the system is. This is not any material that we're putting in here. We're putting in information. So the input, for what am I doing? The voltage system? There's a voltage system here, and I put in input. About this thing here. Well, these days I'll figure out why my screen doesn't match the projector, but nevertheless. So I'm going to put a percent in here. The voltage system, we'll go down and look at it in just a few minutes. Voltage system has an electric motor, drives a generator, and puts out a voltage. So for the voltage system, this thing over here is voltage. And for the white team, your voltage range is 0 to 10. But it doesn't tell you anything about the percent. So, it's trial and error, I think, white team. We put in a percent, because the percent is what we can control. By the way, I drew that diagram wrong. I'm going to redraw it. Try to draw the system in red. That means I cannot change it. The input I have total control over. I can put anything there I want to. The output is what comes out. The system tells me what that is. I can't mess with that. The blue is my domain. That means I can mess with this any I want to. This is up to system. Can't change the system. The system is the system. So I need to decide what input percent here. If I put in too high, I might go above 10 volts, right? So I'm going to put in 30 just to see what happens. First time a team has ever had this kind of range. 0 to 10. I'm going to run this. Here's the experiment. Here's a graph. Here's time on this axis here. And here is percent input. This is the input value in percent. And 30 is the value. This is 30 on the left-hand axis. And this is output volts over here. How many? Oh, look, it says it's 100% done. So it's like about 1.2 volts, ballpark. So this is an experiment that is within your range of 0 to 10 volts. Well, this is a valid experiment for that team. Don't tell them that because I want to know. This is teamwork now. Everybody in your team is working together to do these experiments and analyze the data. That doesn't mean What that means is, what was my percentage? 30? Let's say I'm a member of your team for the time being. I did a 30. None of you have to do a 30. I've done it. Percent input. You don't need to repeat that experiment unless you. What time you got to be there? 4. Okay. You're on the speed team, right? Oh, by the way, Sarah's on your team. Whenever a teammate is not present, guess his responsibility is to bring that team member up to speed.
Rest of the team.
The team, they're the team members. So if you have to leave early, well, you only need to, you know what I mean? Now, what do you notice about that data, that curve? What do you notice? What's something about that you notice?
Lots of fluctuation.
Lots of fluctuation. Who said that? Yes, lots of fluctuations. That's life, students. Things fluctuate. Do you know that there is, and this is one of my sayings, you can write this down if you want to, there is nothing, zip, nada, in the entire universe that does not fluctuate. I haven't done any experiments to prove that, but I'm standing next to it. All right, so what we're interested in here is the average value of that number. First of all, this stuff over here, we're not interested in that. We call that transient startup crap. Everybody say that. Watch your language, you get in trouble. So after it gets here to what we call, can we call that steady state? Say yes, students. I mean, yes, Dr. Henry.
Yes, sir.
We can call this steady state, even though it's, what's the word you use?
Fluctuating.
Fluctuating. So we can get the average of that value. What's the easiest way to get the average of a lot of numbers like that?
Linear interpolation.
Trend line.
Don't like trend lines. What did I say? Trend lines. I don't like trend lines. You can put that down too. Write that down in units. I don't like trend lines. Excel. There's a program called Excel that you can put numbers in and it gets averages for you real easily. So you can put this data into Excel by clicking on this thing right here. I don't know if that works for 2007 Excel. Somebody let me know. I know it works for 2003 Excel. By the way, does it occur to you that some of your team members might have a different version of Excel than other team members? If you have a 2003 office set up, you can get free converters so that you can read 2007 stuff. So I don't want any crying and moaning about, I couldn't read his data. That reminds me of something about Blackboard. There's certain characters that you cannot use in the file name of Blackboard. You know how to find out what they are? Go to the, huh?
Trial and error.
No. I'll show you how to do that. This is sort of an aside. Did I new window? Oh, I didn't like